Oh, how was that? You what?
Oh, it's okay, bro.
Okay.
There are marks, but
You might have any. No, no first.
Okay, we have here, boys. This was a mock 5 last week. Choose from the oxides to answer the question: aluminium, carbon monoxide, carbon dioxide, calcium oxide, iron 2, water, sodium oxide, sulfur dioxide, silicon oxide. You want to download the paper? You have? Each oxide may be used once, more than once, or not at all. State which of the oxide is solid made during a thermal decomposition of a limestone. Limestone is calcium carbonate. So when a calcium carbonate is there, calcium carbonate decomposes into calcium oxide and carbon dioxide. So that's why react with both acid and alkali. Means it's an amphoteric oxide. Only like in your course, just learn like three amphoteric oxide. There are more, but learn 3. If any additional is there, that they will provide an information. But aluminum oxide, zinc oxide, and lead oxides are the 3 amphoteric oxides. Zinc and aluminum, yes. But lead is common question is there with zinc and aluminum. That's why. Has a giant structure. So we have a silicon 4 oxide which has a giant covalent structure. Has an ion with an oxidation number of a +2. Yeah, aluminium here is 3+. Carbon is there. Iron is there 3+. Calcium is there 2+. Group 2 elements. Turns anhydrous copper to sulfate blue. So H2O water, because that is also a chemical test to check the presence of the water.
So can we write like the number of waters, like whatever we figure, like can we write like by ourselves the amount of water? Like
5H2.
Yeah, like 5H2, or can we write it like 6H2?
No. It's a fixed chemical. Whenever a chemicals are formed, it always form in a definite proportion, fixed proportion. You cannot change that. It's made by during a fermentation of glucose. So what is glucose fermentation produce ethanol and carbon dioxide. Group 1 includes the element lithium, sodium, and potassium. State 2 physical properties of lithium.
So can conduct electricity.
Ductile. For group 1. Ductile means like it can be stretched into wire, and malleable means can be hammered into shape. These metals are usually soft.
Soft, so they can be
Soft? Okay. No, these difficult to deform these metals. Malleable and ductile is a characteristic property of these transition elements. The layers can slide without passing each other, without breaking down. So,
Malleable.
okay, I will tell her to deliver this.
चलिए extra बिल है
Extra
Low density and good thermal conductivity.
आटा पे स्पेसिफिक
So 1D, which has an oxidation number of 2+. So 2+ is a group 2 element. This is a group 2 element. That's a calcium oxide. The next is potassium react with the cold water. Potassium react with the cold water. Potassium plus water gives potassium hydroxide plus hydrogen. State the term of electron by potassium is reducing agent. Reducing agent itself, it is oxidized. It's a loss of because potassium is losing electron. It has lost an electron. That's why we call that because whenever it's about reducing agent has the same meaning as oxidation. And oxidation is a loss of electron. State the oxidation number of a hydrogen. Element state oxidation number is 0. What is the oxidation number of potassium? 0. Because it's element. What is the oxidation number of hydrogen also? 0. Because whenever you have an element, even it's a monoatomic or diatomic, oxidation numbers are Zero.
What a property that creates transition.
What?
They are compared to transition elements,
Which property?
the property of picture.
No, general properties we need. Stay include like two physical properties of this, not comparative. Describe what is observed during this reaction. It's of 3 marks. So how to score 3 marks? We will see gas is there. Whenever gas is there, we can say phase, bubbles, or effervescence. When you see the
You
reactant,
can write only bubble.
yes. When you see the reactant was solid. So what will happen? The solid disappear or solid side decreases. What would be the third property?
Color
No, it's already a colorless.
Colorless.
Solution is already, water is already colorless. Colorless thing turn into colorless thing. What you will observe?
Gas
Yes,
bubbles.
Bubbles are already there. I mentioned.
You
The
will say
they will be
Heat given out. Reaction is exothermic. So beaker appear observation. So beaker appear to be warmer. That you can mention. What else? A potassium is a metal. Alkali metal. Alkali metal can catch fire as well. So what will happen? We'll also observe a purple flame.
Okay.
Because of the potassium metal, it's a highly reactive metal. It burn when potassium burn. It will give a purple color as well. Should not be colorless. Marks for colorless. What? Show me. I will tell them what. Okay. He showed. Same thing. No, hydrogen is produced is there. No, it should be deducted 2 marks here. So how it is a burning reaction? What happened? When you add group 1 metal or alkali metals to the solution, water, the temperature increase and that burns the metal. When it burns the metal, what will happen? The metal will give a characteristic flame color. So if a potassium metal is added to a water, we'll observe what is the flame color of the potassium? It's purple or lilac. Same thing, if you add a sodium metal, because a reaction is exothermic, which increases the temperature, and it reacted with the surrounding air as well. So if you add a sodium metal to a water, what will happen? It will also give a characteristic color. It will give a yellow color flame. So all alkali, they give a specific color. If lithium is there, it will give a red color flame. Okay.
How do we know that?
Reaction is exothermic. Group 1 metals, all their reactions are exothermic. So they don't have any endothermic reaction. Are very thorough. What? Yeah, they have the marking scheme. I share the marking scheme.
Oh,
A sample of a sodium chloride is tested using a flame test. So if we test us, because it contains a sodium metal, so what is the observation of the flame color?
yellow.
It will be yellow. Yellow. What they give mark?
Orange
Yes, sir.
होगा.
Give me your paper back. I will talk to them.
फिर वो तो बात सही कर रहे हैं. मुझे दिख रहा है.
Yellow.
चले मैं सब मेरा काट दिया मेरे साथ कोई नफरत हुई है एग्जाम मेरे का पकड़ के मारो.
This question is about the preparation of the salt. Zinc chloride is insoluble salt. It is prepared by reaction of insoluble base with a dilute acid. The equation for this reaction is shown. Zinc oxide plus hydrochloric acid gives zinc chloride plus water. A sample of 3.5 grams of a zinc oxide is added to 50 cm cube and 1 mole per dm cube hydrochloric acid. Show by calculation zinc oxide is in excess. Whenever a question is there, you need a substance to be in excess. First thing, you will find the moles of both reactants.
Yeah.
First, you will find the moles of zinc oxide. How many moles of zinc oxide are there? So moles equal mass in gram divided by molar mass. Molar mass of a zinc oxide, you will use the periodic table. Zinc plus, I guess 64 plus oxygen is 65. So 65 plus 16, 81. You got 0.04 moles of a zinc oxide. Then you will find the moles of HCl, hydrochloric acid. Moles is concentration times the volume. The concentration is given 1.2 and the volume is 50 divided by 1000. So What's the answer? 1.2 into 50 divided by 1000. What's the concentration?
0.0.
What's the mole? 0.6. Now,
0.06.
0.06. Okay. So now we'll take a mole ratio between a zinc oxide and a hydrochloric acid, 0.04 and 0.06. When we take a mole ratio, we divide it by the smallest value. So the ratio is 1:1.5. This 1:1.5 is the mole ratio. Okay.
Yeah, but we can also say by the number of moles that it's more than that.
Yes, you can say in different ways. This is one of the way. You work out the mole ratio. The mole ratio is 1:1.5. What is the mole ratio according to equation? 1:2. Means for a complete reaction, you need 2 moles of HCl. If there is a 1 mole of zinc oxide, you need 2 moles of HCl. But you don't have 2 moles. You have only 1.5, like the ratio. If there is a 1 mole, you have only 1.5, but you need 2. So it means HCl is limiting, and other way we can say zinc oxide is in excess. Yes, you can write this statement as well. This is fine. But the simple way of comparing them to know an excess or a limiting, what is the rule? We work out the moles of each reactant. Then we take a simplest ratio and we compare that simplest ratio with the equation. Let's say if we do this all and we got the answer for a zinc oxide and HCl, we got the answer 1:3. Then which is in excess? When I take by calculation, I got a ratio 1:3, but it should be 1:2. So which one is in excess? It means HCl is in excess. HCl in that case. Because I have 3 moles of HCl, but I don't need 3.
1 mole.
I need only 2 moles of HCl.
So we can just
So it's always a comparison between the moles. It's always a comparison between the moles from calculation and the equation. So in the calculation, we got the ratio 1:1.5, but according to equation, it should be 1:2. This number is smaller. It means HCl is less. Like we don't have enough HCl. So HCl is limiting or zinc oxide is in excess. Just a minute, I'll see. So we'll continue after a break.